notes. Our next speaker is Dmitry Shigel from GBIF, who you know very well, from Copenhagen in Denmark, and he's going to talk us about mapping and publishing sequence-derived data. And he's prepared a video for us, oops, which I'm just about to share with you all. Okay, can I just get a nod that you're seeing that in full screen and that looks good? Then I will play.
I'm Scientific Officer in the GBIF Secretariat. Today I will give you a brief update on the DNA-derived biodiversity evidence in GBIF and on related news in this area of our work. The amount of digitally available biodiversity data in the world depends on our efforts to capture and standardize different types of data, and of course on how digital ready these data types are. DNA-derived data play an increasingly important role in our knowledge on the world's biodiversity. It is one of the most rapidly developing and rapidly growing data streams. There are at least 3 biodiversity data avalanches that we are facing: citizen science data, remote sensing data, and eDNA. Of the 3, citizen science data is probably the easiest one to integrate into the global biodiversity data ocean. And as you have heard already at this conference, is one of the most advanced in this integration. Remote sensing, traditionally underrepresented at TDWG, still have some way to go towards interoperability among individual data sources and with other types of biodiversity. But citizen science and remote sensing data are not going to help demographic biases of interest and taxonomic biases in digitally available data. Likely, they will make it worse. There is a limit of how far in your biodiversity exploration you can go with optical instruments and morphology. So the reason why I love eDNA data stream so much is because it is our main hope to write in the invisible, life in the soil, in the oceans and freshwater, the dead wood and fallen leaves, and inside organisms. Luckily for us, DNA data is born digital. Still, sample and specimen metadata needs to be captured in a good way. In the following slides, I will tell you where we are with DNA-derived data in GBIF, and then present the new guide to publish such data through non-molecular data portals. This will be a complex slide, but it's good to go through the general schema so you can better see how different progress elements work together. First of all, DNA allows delimiting provisional taxa or operational taxonomic units. But the same molecule allows us to chemically detect species occurrences. The availability of traditional and of provisional names makes possible indexing occurrences no matter where they come from. At the moment, DNA-based names come to GBIF taxonomic backbone from UNITE and from both. There are many ways to generate occurrence data from DNA. These occurrences can be of individual species or of species mixes. A range of approaches and technologies is in active use to generate both. All this is done by sequencing, machine reading of species-specific fragments of DNA. In GBIF today, individual DNA-based occurrences come from International Nucleotide Sequence Database collaboration, commonly known as GenBank, and from Barcode of Life. DNA-detected species mixes come from Magnify and some other projects and initiatives. In fact, you don't have to sequence if you know what you're after and if you have chemical means to detect target species. PCR-based detection is cheaper, faster, and is widely used in more applied contexts. We expect that the entire GBIF community will soon join publishing all these DNA-derived data through GBIF. In fact, most of you know all these data publishing steps already. In GBIF, names are published as checklists, individual occurrences as occurrence datasets, and species mixes as sampling event datasets. It is only data mapping that requires some additional learning. Let me illustrate a little bit. DNA-based names are called OTUs, Operational Taxonomic Units. At the moment, they mainly come from UNITE for fungi and from Barcode of Life for arthropods. We're developing new collaborations, and we can expect prokaryote, protist, nematode, and diatoms in this OTU space. These stable OTUs are provisional DNA-based names, which were not formally described, and there is no Latin name for these provisional taxa, just codes. Researchers repeatedly come across these OTUs in their samples. Millions of individual occurrences come from International Nucleotide Sequence Database collaboration and from Barcode of Life. We just had very good discussions with the technical teams of both partners, and we are in the process of making the connection between them and GBIF more dynamic using API. In the species mixes space, Magnify is a champion contributor of metabarcoding data. Over 20 million new records, mainly from marine environments, and of the taxa still poorly represented in GBIF. However, last year at the Biodiversity Next conference, we realized that there are about 12 people on the planet who know how to resurface DNA-derived data through general biodiversity platforms such as GBIF. 13 authors from Australia, Norway, Sweden, Denmark, UNITE and GBIF spent about a year putting together, based on our practical mapping and data publishing experiences, a cross-platform cookbook of publishing and mapping instructions. Early work at TDWG, GGBN, Genomic Standards Consortium was very important to make these recommendations possible. We're nearly done with the final edits. The guide is already online, and we aim at releasing version 1 in 2020. There are two main sections in the guide. One is an introduction that helps people already familiar with data publishing to have an efficient start with DNA, and also for the molecular people to become familiar with our data publishing routines. The guide will help you to stop and think about what kind of data you're about to publish, and what is the best way to resurface the DNA-derived data through the biodiversity discovery platforms. Data publishing easily becomes a self-sufficient activity, something to do and to forget once done. Smart data publishing is supporting uptake and use. Therefore, it's very important to publish biodiversity data with user needs in mind and to choose the best way of packaging the data. The core part of the guide is a data categorization and mapping advice. This section walks you from data type to data type, field by field. If you are a guru already, you don't need long texts and introductions. You need mapping tables which tell you which fields are for what, provide examples, descriptions, and how important is the field. A new Darwin Core extension contains fields critical for adequate indexing and interpretation of DNA-derived data. It is called DNA-Derived Data Extension, and it is actively edited in parallel with finishing the guide. When the guide is ready, the work on the DNA data stream will only start. Now we have finished experimenting, and we're confident that we know how to resurface DNA-derived data through GBIF. We have also put together a detailed guide on the process. However, as we know from experience, dedicated training will make it even better. The guide is basically a ready textbook, and we have been developing a course that would provide students, we're focusing on the higher education to start, with necessary data skills to work with GBIF and with Barcode of Life. We introduce publishing and using traditional and DNA-derived data. We bring key concepts and practical skills. We hope that the course is taking place first time next year in Georgia in South Caucasus. Work on this course is a collaboration with the Biodata project and GBIF Norway. Thank you very much. Let's be in touch. Please consider publishing DNA-derived data through GBIF and take a look on our guide.
Great, thank you, Dimitri. Hope you saw that all okay. Let me just, sorry. I just need to get back to the notes again and see what's going on. So the notes are, questions are coming in fast. Yes, Paula, as you might expect, wants the training documents in other languages, and I can totally agree with that. I'm sure you don't disagree at all.
No, and so what is great with the Biodata project is that we have already realized like the need of and the power of languages. We have translated the GBIF training materials into Russian, and we successfully used them in Belarus and Tajikistan in 2019. And I can say already now that without that translation, the success of this training will be very different. So, and I mean, following up from yesterday's great session, highlighting the value of languages and recognizing like strong English dominance over TDWG, I think we need to find a way to do that. I mean, you would still need a good master version in English, and but an easy way to cascade update the language variants. I mean, we've been using crowd-in GBIF, and I think this is the tool which has a great potential for that.
Great. So there's a question from Annie Simpson. Where does the term eDNA fit into your schemas?
Yes, this is a good one. So we come across so many terms. So the guide actually, we decided to have a glossary in the guide because people use metabar coding, whatever eDNA, and nobody really knows what they mean except people who do that routinely. So eDNA, environmental DNA, is a funny term. There are people who hate it because all DNA is environmental, and but then there are people who say that if you don't have a visible organism behind, and you, for instance, sequence soil or seawater, you basically detect past presences of the organisms. So most of the eDNA data feeds into this metabar coding sampling event corner of my complex slide.
Yeah. From David Shorthouse, there's a question, is there content in recorded by, and if so, what do you put in it? And I know for a fact there wasn't, because I put an issue on GitHub for this. So what do you think about recorded by?
I don't have a ready answer for that. So there is always a kind of, in any mapping schema, there is always a compromise, and there is some decisions to be made between document everything you can and to have minimum publishable kind of set of fields. So we have not finished reviewing all the issues, and we'll be back to recorded by in the coming weeks. So if you're interested in joining these discussions, and I invite you to see the collection of GitHub issues, which is linked from the guide page.
Yeah, hopefully we'll put that link into the chat, into the document as well. That'd be quite useful. I mean, if you don't mind me pushing in and asking a question myself, if you have a specimen of something that may be a specimen of soil or something, and then you create all the specimen details from that, and you have that in your specimen catalog, then you push data to ENA, for the DNA data to the DNA database, and then you pick it up and bring it into GBIF that way. ENA's data model is very simplistic. For instance, it doesn't handle things like recorded by very well. And what you'll effectively do is filter the data through that poor data model and before it gets to GBIF? Or have you got a way to link everything together so you still know that you should get the detailed data from maybe the collection database?
Yeah, so that's a very good one. And so we had discussions with ENA, and as many of you know, GenBank has very low publishing threshold, and that was by design from the beginning. And I think this is part of their success, that it's relatively easy to publish data through GenBank, through ENA, but then that is easy because you're free to skip so many fields, and people do. If it's not obligatory, you'll see gaps in the content. So there are a range of ways how you can resurface your sequence-based data through GBIF. One is indeed to push it through ENA or barcode of life with whatever fields you put there, and then see it reappear in GBIF and OBIS and so on and so on. The other way is to use a richer model. We would not recommend creating intentional duplicates, but if you do, then the new clustering mechanism just introduced by our informatics team would allow detecting that several instances of the same biodiversity evidence grain exist in more than one places. So you would see a simpler version of the same record at ENA. You may have a much richer version of the specimen it came from as a result of the digitization of museum collections. So in the future, I hope that clustering will allow some sort of compromise and deduplication. Yeah, thanks. Team just put the clustering link there. So, and clustering ideas were very well received by the NA people we just spoke to. So I think they're also interested in seeing that happen.
Yeah, I see Tim has pushed the problem back to the attribution task group. So he's put the ball back in our court. Very nice. Just moving around rather quickly here. So Doug Erison says, a new evidence class in Darwin Core with an attribute for who created the evidence might be better than overloading recorded by. I'm not sure that's a fair question to you, Dimitri.
No, it is not.
I think that's actually a question for us in the attribution task group to think about.
Yes, this is why I love TDWG. Very quickly you realize that, oops, that's the limit of what I know. Go back and learn.
Okay, Esteban Marentes, will the extension for mapping be approved soon?
Approved by TDWG.
I assume you meant the extension, the DNA extension you were talking about.
Mm-hmm. So I guess there are two main ways to kind of introduce extensions and see them being used. One is to formalize it first and then seek ratification and then hope that people will pick it up. The other one is just to try and use it and make sure it works in your system and then expose it to TDWG as something that's been tested already and then seek ratification later. So I think we're following the second approach.
Yeah, that's the one the executive don't really like.
No. But
so I'd encourage you to at least compromise a little, go halfway.
But as soon as we are kind of 100% sure that yes, this is how community is happy to use it, I think this will be a perfect moment. So hopefully before next TDWG, it is submitted. I'm not the main author of the extension, so I can't really speak for people who spend nights and days and days creating it. So, but yes, noted.
How do you know the community is happy with it until you've made a task group to engage the community?
I'm a content person. When the content comes in, I see it works. So.
Okay. That's all the main questions. There's quite a few comments there, but maybe you can address them offline. And we can move on to the next presentation. Paula, you want to do the recording?